Hello ladies and gents, I decided to give you guys a video because a bunch of people did not finish their homework yesterday. So if you did finish your homework, you can get started on this and go from there. I know you guys haven't had a video with me before, but what's going to happen is I will go through the stuff. When you need to pause, you can pause and catch up writing. I will give you this noted sheet, which you should already have in front of you. You can kind of just follow along, okay? So hopefully it all works out for you. So we have scale drawings, and we usually use scale drawings like with maps, because obviously I can't draw a real live map that's the same size as what something actually is. Or like when we shrink photos, go like a really big painting to a really tiny painting, okay? So that's when we use scale drawings. Or like when you're drawing a house, you obviously can't draw a house on a piece of paper that's the same size as your real house. So you need to have plans that are small enough that somebody can use it and then actually build the house from that in real life, okay? So we have what's called a scale factor, and that's just the ratio between the scaled drawing and the actual photo, okay? Or the actual print, whatever we're using. The actual length, okay? So maybe length is a better word there, okay? So when we want to find the fraction or the ratio or the percentage, you're always going to do the reduced length over the actual length, okay? So that's what this fraction is going to equal. So always the new length over the old length, okay? So this would be like new over old. Because this might be like the reduced, maybe we're enlarging it, okay? So this could be or enlarged. Okay, so that word is enlarged there. So enlarged or reduced length. So the new over the old, okay? So if I'm looking at this, a photocopier wants to reduce the size of this poster to a smaller size. So we're going from this big poster, so there's some little guy on here, right? And they want to go to a smaller little guy, okay? What percent, so we're going to eventually find the percent reduction they should choose. Now, it doesn't matter which one you go with, but like 20 goes with the 4, right? Because it's the smaller side of the rectangle, and then the 30 goes with the 6. Now, no matter which one you choose, you'll get the same answer. But I start with the reduced length. So the reduced length is 4, right? Because this is my new poster. Over the actual length, which is 20. And I'm going to simplify that to 1/5. Now just to show you that it works, if I did the smaller length 6 over 30, that also equals 1/5. Okay? So now I have a fraction. This is my scale factor, but they want it as a percent. So what is the percent of 1/5? Okay, so 1/5, I can make that look like 100 on the bottom really easy, right? By multiplying by 20. So it's going to be 20 over 100. So this equals 20%. Okay, so it's a 20% reduction that I'm going from this big picture to this small picture. Okay, so just to review, I made my fraction. Okay, now a lot of your problems today, the fraction is going to be all you need. So I went from my new length to my old length. Okay, new over old, new over old. And in this case, because it asks for a percentage, I just converted my fraction. I know as soon as I get 100 in the bottom of my fraction, whatever my top number is, that's my percent. Okay, or you could have long divided and did 5 into 1.00, right? And you would have gotten 20 as well. Okay, either way is fine. But this way is probably shorter, okay? So let's do the same thing. This time we're enlarging it, okay? So trapezoid B has been enlarged to produce trapezoid A. Find the scale factor. So again, I would have the enlarged over the actual, or the new over the old, okay? Now this one, they don't give me any, they don't give me two sides, right? They only give me the one side. So the new one, I'm enlarging it, is 7.8 over 2.6. Okay. Now this is not the nicest decimal, right? I mean, it's doable, but let's just divide it in the calculator. Okay. And it's 3. So this would be 3 over 1, which equals 3. Okay, so my scale factor is 3. I need to multiply this by 3 in order to get to 7.8. Okay. And again, that's my final answer. In this case, it didn't ask for a percentage, so I can just leave it as the scale factor, okay? Go ahead and pause it if you need to catch up here. Now this is where it gets a little more interesting. So it says the scale of a map is 1 inch to 25 miles. Okay, so that's my important part. Let's highlight that information here. 1 to 25 inches. Okay. If the length of Whitley Road is 4.4 inches, find the actual length of Whitley Road in miles. Now for these problems, some of you are going to be like, well, I automatically do 25 times 4.5 or 4.4. The thing is, if this isn't 1, or if one of these numbers isn't 1, it's going to make your life more difficult because you're going to be like, okay, what do I multiply by? What do I divide by? So I'm always going to set up a proportion, which we know how to do. Okay, so 1 inch goes with 25 miles, right? So I'm going to have 1 inch over 25 miles equals some inches over some miles, right? Now we have this 4.4 inches, so I'm going to put that on the top because inches go with inches, right? And I'm trying to find my x miles. Now remember, with proportions, I can do my butterfly method, the crossover method, whatever you want to call it. So I'm going to do 1 times x equals, oh, I can't see red, hold on. Let me find a different color here. And 25 goes with 4.4. Okay, so that's 25 times 4.4. And 1 times x is just x, and I'm going to do 25 times 4.4 on the calculator. And as you can see, when I do that, I get 110. Oops, 110 miles, okay? So if I am trying to figure out what Whitley Road is, it is actually 110 miles in real life, even though it's only 4.4 inches on the map, okay? So very similar example. The map scale is 1 inch to 15 miles. Liz is 0.6 inches from school. What is her actual distance? Okay, so again, I'm going to do 1 inch over 15 miles equals whatever inches over some odd miles. Ooh, okay, so I'm going to have 0.6 inches and x miles because I'm trying to find out her actual distance. So again, butterfly method, 1 times x is going to equal 15 times 0.6. And again, because that's just a little more complicated than I want to spend time doing, I'm actually just going to punch this in the calculator. Oops, sorry. 0.6 is just 9. So x times 1 is just x, and 15 times 0.6 is 9. So that's 9 miles. I should make sure that I add that in, okay? Go ahead and pause it if you need to right here. My next example is the actual distance between Mrs. Younker's office and her home is 120 miles, okay? This is not real life. 120 miles. A map uses a scale of 1 inch to 50 miles. How far apart is her home from her office on the map, okay? So I'm actually going a little bit backwards. Instead of finding miles, this time I'm going to find inches. So I still have my 1 inch to 50 miles, okay? Equals, well, some inches over some miles, right? Now miles is what I have this time, right? I have 120 miles. Oop, what happened here? Okay, I froze for a second, sorry guys. And I'm trying to find my inches, right? I still do butterfly method. So I get 1 inch times 120 miles, which is going to equal 50 times x, right? Now 120 times 1 is just 120 equals 50. I need to divide both sides by 50 to get x equals, and if I do 120 divided by 50, it's going to be a decimal. And I get 2.4 if I do that, okay? And that's 2.4 inches. So on the map, it's only going to be 2.4 inches long. Okay, so you can kind of zoom out and look at all this again. Okay, now this is an exit slip. I don't usually do these, but I'm going to have you do them with the notes. That way I know you're paying attention. So the map scale is 1 inch to 15 miles. CJ is 3 inches from the school. What is the actual distance? So that's going to be very similar to what we just did in this last problem, okay? So I'm not going to show you how to do this one. You got to do it on your own, okay? Then you can go ahead and start the homework, okay? Have a wonderful day. We'll see you tomorrow. Bye.